morning, friends and dear students. It gives me immense pleasure to be here again for my course, Flight Mechanics. This course belongs to the fourth semester Aeronautical Department, Institute of Aeronautical Engineering, Hyderabad, India. As of now, I have completed all the 5 units. I am in the last 3 classes are left, and in my previous classes I have discussed about in first module about introduction to aircraft performance, second module cruise performance, third module climb performance, fourth module maneuvering performance, fifth module landing and the takeoff performance. After that, I have completed the 15 lectures of numericals, problem solving, then definition and the terminology of this course. Now I am in the final phase where discussion on the question bank and the solution, and today I am in the climb performance. I am Dr. Yagya Dutta Dwivedi, professor from Institute of Aeronautical Engineering, Hyderabad, India. Today's lecture I am going to take about overview of the topics, just climb questions bank related to the climb performance, question bank related to the descent performance. I will go for my question number 1, which is discuss about climb and its importance. So I will be discussing about climb. In aviation, a climb is the operation of increasing the altitude of an aircraft. It is also the logical phase of a typical flight, the climb phase or the climb out, following takeoff and preceding the cruise. During the climb phase, there is an increase in altitude to the predetermined level. So if I talk about this, so this is the aircraft. This is our tail. This is here a wing. This is hydraulic tail. So if I talk about the climb, so this is the horizontal. So this is the climb angle gamma, and your aircraft is moving in this way, and it is altitude of this aircraft is increasing. So if I talk about this profile, so this is the takeoff, then after that it is climb, after climb it is cruise, then it is descent, and then landing. So this climb, it is the ground, and this is the altitude. This altitude your aircraft is achieving, and your aircraft will climb in this position. Now I will go for the question number 2, which is outline about descent performance and discuss its importance. So as of now, you have seen that I have discussed in the previous question about the climb. So this is the takeoff. From here it is a climb. From climb it is a cruise. In between it is a maneuvering. Then it is where it is. This is the descent, and this is the landing. So this phase is called the descent. So in this descent, the altitude of the aircraft will decrease. Thrust required is a minimum. So descent during air travel is any portion where an aircraft decreases altitude and is the opposite of an ascent or the climb. So if you see in the climb it is going upward, but descent it is going downward. So this descent is the opposite to the climb performance. Descent are part of normal procedure, but also occurs during emergencies such as rapid or explosive decompression, forcing an emergency descent to below 3000 meter or 10,000 feet, and preferably below 2400 meter or 8000 feet, respectively. The maximum temporary safe altitude of an unpressurized aircraft and the maximum safe altitude for an extended duration. So, in case of emergency, the aircraft has to fly up to 3000 meter, or it can fly up to 2400 meter with the maximum temporary safe altitude for an unpressurized aircraft and the maximum safe altitude. Now I will discuss about question number 3. Illustrate the best climb angle, rate and the normal cruise. So we have to see the best climb angle, rate and the normal cruise. So just now I have discussed about the climb. This is the climb angle and the best climb angle and how much the rate. So it is a rate of climb, that is the, this is the V. So this part will be V sine gamma. This is called rate of climb. So best, how much is the best? That is the criteria, and that we are going to discuss here. So here if you see, we have the different aircrafts here. There is a tree or any elevated pattern here. So best angle climb, that is called Vx. So maximum altitude with minimum distance. So if it is the best angle climb, so it will take the maximum altitude. This will be the highest and this will be the minimum. If you are flying in this type where altitude is high, so this is used when you want to override some high altitude zone or some trees or some hill or some tall building. That time best climb angle is used. Best rate climb, it is a maximum altitude with the shortest time. So if we tell about the best rate climb, so this best rate climb with a minimum time with the shortest time, maximum altitude to get, that is called the best rate climb. Then normal or the cruise climb. Cruise climb, maximum, it is a maximum forward visibility and engine cooling. So this is the maximum forward visibility and the engine cooling. That is the, for a high range, for a long time, we cannot go very high angle climb or best angle climb. Best rate climb also we don't fly. But if you want to go for a high range, we have to go for a normal cruise climb condition. Now we will talk about the question number 4. Discuss about factors affecting climb performance. So what are the factors which are affecting for the climb performance? So here we have the factors affecting the climb performance, that is climb angle and the rate of climb. So in this we can see first speed and the acceleration. First is the speed and acceleration. This is the first point. As much you have the speed, high speed, as much you have the high acceleration, your climb rates and climb angle will be high. Then aircraft mass. aircraft mass should be as low as possible. Then third one is the temperature and the air density. So if you want to fly in a high temperature, or if you want to fly at a high altitude where density is less, there the climb rate and the rate of climb and climb angle will be less. So if rho is low, ROC will be low. Same way, if temperature is low, the rho will be high, ROC will be high. Next is wind. This is also depend upon the wind condition. So if it is a tailwind or the headwind, aircraft is moving in this direction, and if this is the headwind, in headwind the ROC is good, rate of climb is good, as V infinity will be high during headwind. So every pilot wants that aircraft during landing and the takeoff, whenever they want the high climb, the relative wind should be high, and this will be happen when the air is coming from the front. So your relative wind will be high, and if it is a tailwind behind, it is called the tailwind. If it is a tailwind, then it is not good because the relative velocity will be less. Assume that if aircraft is flying at 300 kilometers per hour and headwind is 50 kilometers per hour, so relative wind will be 300 plus 50, 350 kilometers per hour. So if you take the lift is equal to half rho V square. So this V is a relative wind, V infinity. So this lift will be high during. So we need a headwind, and if it is a tailwind of the same speed, so it will be 300 minus 50. The relative wind will be 250 kilometers per hour. So as per that, we have to discuss. We have to see that what is the direction of the wind. Next point is the retraction of the flap and the landing gear. So during the landing gear, if it is fully out, then there will be a lot of drag and the lift will be reduced. If you want to lift up, flaps should be down. If you are making down, then angle of attack is increased. So this is your wing aerofoil, and here if we make a flap, this is the flap. So now the camber is increased from here to here. So net angle of attack is also increased. So flap down is requirement. Retraction of the landing gear should be inside. It should not be out. And the cabin pressurization is also very important. If you are making a high rate of climb, then cabin should be pressurized. If it is not pressurized, the passenger will feel very discomfort. There will be some problem. The health issues may come, blood pressure, and your ears drum may be vibrating. So you will have lot of problems. So if you are having high rate of climb, then it should be always recommended that cabin should be pressurized. Question number 5. Interpret the rate of climb with mathematical formulation. So this rate of climb, if you see here, imagine that you are flying an airplane and you suddenly encounter a major obstacle ahead, a large building, a hill, or even a mountain. The ability of your airplane to fly up and over such obstacles depends critically on its climbing characteristics. Or imagine that you encounter bad weather or turbulence at some altitude and you want get out of it by climbing quickly to higher altitude. That time this climbing performance is very important. So if you see here, if I make the aircraft, this is the horizontal, this is your velocity, this is the gamma, this is the weight, this is the your lift, and thrust is also in the same direction, this is the drag. So if I make here equation for this, so this lift is equal to W cos of gamma, this is the gamma, and thrust is equal to, so lift is equal to W cos gamma and thrust is equal to D plus W sin gamma. So now from here we can say that the cos gamma is equal to L by W, or gamma is equal to cos inverse L by W. So if this lift and the weight, they are very important parameter for finding the rate of climb, and we know that to have the maximum rate of climb, this L by W should be high, means lift should be high comparing to the weight. Now discuss the effect of wind on climb and descent performance. I think I have discussed just now. So again I will. So just now I told you that during climb, the relative wind should be high. This will happen if the headwind is coming in front of the aircraft. So this is the aircraft. Aircraft is moving in this direction. If this is the headwind, the relative velocity V infinity will be aircraft velocity V plus headwind. So if this is the 500 kilometers per hour and this is the 50 kilometers per hour, so net velocity is 500 plus 50 is equal to 550 kilometers per hour. So lift is equal to half rho V square S CL. So this V here is this V 550. If aircraft is facing tailwind, then just I will draw here again. This is the tailwind. This is the 500 kilometers per hour, and tailwind in the same direction, it is a 50 kilometers per hour. So net velocity is equal to V minus V tail. So 500 minus 50, this is the 500 and it is a 450 kilometers per hour, and here you have the 550 and here 450. This will generate less lift. So lift at headwind is greater than lift at the tailwind. So always during takeoff and landing, headwind is preferred. For low speed flow, calculate the lift to drag ratio for this wing at 6-degree angle of attack. Assume the span efficiency. For climbing, three parameters are essential, known as PAT, that is power, attitude, and the trim. Explain with example. So during climb, PAT means PAT, where P is a power, A is equal to attitude, T is equal to trim. So what is the meaning of power? We know that as and when your aircraft is climbing like this, it is climbing with some angle gamma. So this climbing is very much possible if we have the excess power. Excess power, and what is the excess power? It is power available by the engine and power required by the aircraft. This is called the P-excess. As much you have this value, that much gamma maximum you will get. That much high speed and with high climb angle you can achieve. If you talk about attitude, so attitude indicates the angle of climb. Angle of climb, that is called the gamma here. This you can see, it is the gamma here. So this gamma is called the climb angle. So to have this attitude more and more, you need more and more power required. When we talk about the trim, trim is the condition when all the forces and moments are balanced. Means there is no acceleration and aircraft is trim. This is happening due to the control surfaces like rudder for yawing, elevator for pitching, aileron for rolling. This is rudder is for yawing. This all controls make the aircraft to be trim. So in the trim condition, all the moments will be remain zero. Now we will go for the question number 10, climb rate or rate of climb. Aeronautics, the rate of climb, that is ROC, is an aircraft's vertical speed. The positive or the negative rate of altitude change with respect to time. In most ICAO member countries, even in otherwise metric countries, this is usually expressed in feet per second. Feet per minute. Elsewhere, it is commonly expressed in meter per second. So, all the ICAO members, even in otherwise metric countries, this is expressed as a feet per minute, FPM. And in other countries, it is meter per second. So, how much your aircraft is climbing? Like this. And this is, if this is the gamma, this is the V. So, this is called the V sine gamma. And if your aircraft is climbing in this way. So, this is one of the parameters in which we measure the climb rate of the aircraft. What is rate of descent or the sink rate? So, as of now, for the climbing, it is a rate of climb. But if it is falling down from high altitude to low altitude, this is called the sink rate. The rate of climb in an aircraft is indicated with a vertical speed indicator, that is VSI, or instantaneous vertical speed indicator, that is IVSI. The temporal rate of decrease in altitude is referred to as the rate of descent or the sink rate. So, temporal rate of descent per unit time, how much altitude it is decreasing. So, suppose aircraft is flying here and it is falling like this. So, per unit time, how much this height it is lost. This is called altitude, and from here it is 1000 meters, and after 5 seconds it has reached to the 500 meters. So this is called rate of descent, means 1000 minus 500 divided by 1. So it is 500 meter per second. This is the rate of descent. Here we can see the same thing, how it is happening. This is the diagram. Best angle of the climb airspeed, that is called Vx, gives the greatest altitude gain in the shortest horizontal distance. So if it is a best angle, gamma best, so at airspeed that gives greatest altitude gain in the minimum time. This is a condition for this. This angle of attack gamma is high. So this is called the best angle of climb. And if you say best rate of climb airspeed, that is Vy, gives the greatest altitude gain in the shortest time. It is in the horizontal distance, shortest horizontal. This distance is minimum. Here with a minimum time, this is here. So this altitude with the shortest time here, again in a minimum horizontal distance. So we should be very much careful that best angle of climb airspeed, that is Vx, gives the greatest altitude gain in the shortest horizontal distance. So minimum horizontal, that is Vx, in this is called Vx, the speed. And if you say about Vy, it is a Vy. So Vy gives the greatest altitude gain in the shortest time. So a minimum time required to gain altitude. So we have to clear all the obstacles here. But if you want to, nearby some tall buildings are there and you want to fly, then we have to use the Vx. That is the best climb angle velocity we have to fly. That is Vx. And this is the Vy. Discuss the climb angle. So climb gradient is the ratio between the distance travel over the ground and altitude gain, and is expressed as a percentage. So if I talk about this is the ground travel distance. Okay, ground travel over the ground and altitude gain, and how much altitude it is gaining. So it is the x and this is the y. So it is a ratio in the percentage. So x by y in percentage, it is called the climb gradient. Angle of climb can be defined as the angle between a horizontal plane representing the Earth's surface and the actual flight path following by the aircraft. So here your aircraft is following this path. So your aircraft is following this path like this, and this is the horizontal line. So from here, what is the angle? Gamma. This is called the angle of climb. Illustrate the climb gradient with example. So for example, you are climbing at a 650 feet per minute with a true air speed of 110 knots and a 10 knots tailwind. What is your climb gradient? So here if you see, true air speed is 110 knots and 10 knot is the tailwind. So this will be reduced. So TS plus or minus wind is equal to the ground speed. So 110 minus 10, you will get the 100 knots. Okay. So this 100 knots in this X direction, and you are flying with a 650 feet per minute. So the climb gradient is a rate of climb in feet per minute divided by speed. So here 650 divided by 100, you will get 6.5%. So your climb gradient is 6.5%. Best angle of climb airspeed. Best angle of climb airspeed for an airplane is the speed at which the maximum excess thrust is available. Excess thrust is the difference between the total drag of the aircraft and the thrust output of the power plant. For a jet aircraft, this speed very close to the speed at which total minimum drag occurs. So it is very interesting that this is the thrust required and this is the velocity. So the plot for this will be like this. So this is the TR curve, and there will be, this is the here thrust available curve. This is the TA, thrust available. So excess, the point at which this is the minimum drag that we will be discussing in next classes. So here is the minimum drag, and here you have the maximum excess thrust. If you fly at this speed, you will get maximum rate of climb. That is best angle of attack or best angle of climb. Airspeed for an airplane is the speed at which the maximum excess. So this is the V minimum drag. V minimum drag is the speed at which you get the best angle of climb. Best angle of climb. Next we will discuss the importance of the service ceiling. So service ceiling is where the rate of climb drops below a prescribed value. Service ceiling is where the rate of climb drops below a prescribed value. So if your aircraft is, this is the ground, and your aircraft is flying up to certain here at this altitude, the rate of climb is 100 feet per minute. So if aircraft which rate of climb is 100 feet per minute or more, so this is called the service ceiling. Service ceiling. The Service ceiling is the maximum usable altitude of an aircraft. Specifically, it is the density altitude at which flying in a clean configuration at the best rate of climb airspeed for that altitude and with all engines operating and producing maximum continuous power will produce a given rate of climb. So in this case, all engines are working. It is in a very good condition. Your aircraft will attain the given rate of climb, that is 100 feet per minute. So that is called the service ceiling, and in this service ceiling all the operations are possible to carry out by the aircraft. A typical value might be 100 feet per minute, that is 0.51 meter per second climb, or on the order of 500 feet per minute or 2.5 meter per second climb for a jet aircraft. So for the jet aircraft it is different, for the propeller aircraft it is a different. So now we will discuss about service ceiling. Discuss about service ceiling, absolute ceiling. It is absolute ceiling. The absolute ceiling is the highest altitude at which an aircraft can sustain level flight. So absolute ceiling is the maximum height. Initially your aircraft is here. This is your service ceiling. Up to here you have the 100 feet per minute rate of climb. But as you go up and up, your aircraft is reaching in some point where your aircraft is here. From here, this is the altitude. This is called the service. This is called the absolute ceiling. Absolute ceiling. In this, the rate of climb will be 0. It cannot climb. So absolute ceiling is the highest altitude at which an aircraft can sustain level flight. It cannot climb. It can go straight in the level flight. Due to the thin air at a higher altitude, a much higher true air speed is required to generate sufficient lift on the wing. The absolute ceiling is therefore the altitude at which the engines are operating at the maximum thrust, yet only generate lift to match the weight of the aircraft. So in this condition, if you are in the service ceiling, your aircraft will be generating the lift L, which is equal to the weight only. So for the climb we need lift should be more than the weight. So your aircraft cannot go beyond the service ceiling because your engines are not able to produce the power. Excess power is 0. That point is called the service ceiling. Explain gliding flight with mathematical expression. So what is the gliding flight? In the gliding flight we don't have the engine. Engine thrust is removed, or engine is failed, don't have the power, then it is called the gliding. For the practice we use this type of motion. So whenever an airplane is flying such that the power required is larger than the power available, it will descend rather than climb. In the ultimate situation, there is no power at all. In this case, the airplane will be gliding. This will occur for a conventional airplane when the engine quits during flight, that is engine failure. Also, this is the case for a glider and the sailplane. The forces acting is shown in this diagram. So if you see, it is gliding like this. So lift is perpendicular here, drag is in this direction, weight is in this direction. So equation of motion, this lift will be W cos of theta. So L is equal to W cos theta, and drag will be here. This will be the W sine theta. So D will be W sine theta. If you divide this D by L, so tan theta, so sine theta by cos theta is equal to D by L, or tan theta is equal to L by 1 by L by D. So this is the angle for the, so for the tan theta should be minimum, 1 by L by D should be maximum. The higher the L by D, the shallower the glide angle. The smallest equilibrium glide angle occurs at L by D maximum. So if you want to go a high range, your ground distance maximum, so your tan theta should be minimum. As you have the minimum theta, that much distance you can cover. You can find out the place where you can land the aircraft. So this is called the gliding flight. Illustrate the forces during climb and explain with neat sketch. So illustrate the forces during the climb and explain with neat sketch. So we will see here that here we have level flight in the normal during on the ground. It is moving from here, and in this L is equal to W here. As you climb, you see this lift is now increased this much. As you are climbing again, after level flight, normal lift, climb entry. So during level to the climb, you need more lift. So increase lift, steady climb. As you reach to the steady climb, again this lift and this lift, this is the A, this is the B, this is the C. So at A and at C, lift are same. At B, lift L is more than lift at A and C. So in different situation, you have the different lift. This is very important diagram. We all should understand that as and when this aircraft is going, no problem. As it is just climbing, at that some few seconds, you need more lift. So your engine has to give more thrust. Then only your aircraft. Once it is reached to the certain speed on the angle, then again the lift will be reduced and the aircraft will go in the same altitude. It will be flying. So here we can see that another case, level flight, forces are balanced and the constant here in the lift is equal to weight in the first case, and thrust is equal to drag. Now if you see during the climb entry, drag is high, drag is greater than the thrust speed, so thrust will be falling down, so you have to increase the thrust. Steady climb, forces balanced, constant speed. So in this we have to increase the lift by increasing the speed of the aircraft. So this the previous three, and here they are the weight is balanced. Here lift is not is equal to weight, but lift is greater than weight. Here lift is equal to weight, thrust is equal to drag. Here in this case T is less than drag, so we need to generate extra thrust. Illustrate the forces applied during climb forces, so with the mathematical expression. So this we can see the forces for the climb. Here aircraft is climbing with the climb angles C here. This is the horizontal. This is the thrust line in this direction. Lift will be perpendicular and this is the lift line. This is the weight line in this direction, and here we have drag will be in the same line as the aircraft is moving. This is the flight path. M is the aircraft mass and A is the acceleration of the aircraft. So all the forces, that is lift, weight, thrust and drag. These are the four forces that are considered for this flight. If you see the mathematical expression, so vertical forces F sin C minus D sin C plus L cos C minus W is equal to MA of vertical, and in horizontal F cos phi in this direction, F cos C minus D cos C in this direction minus L sin C is equal to MAH. So these are the forces equation for the climb angle C. Now differentiate between power curve of a jet and the propeller airplane. We know that the propeller and the jet aircraft, they have some limitations. If you see the here, the PR, that is the power required, is equal to D into V infinity. D is a drag, and if you see here, the excess power is very high at this is called the V at minimum drag, and your P available by the engine is equal to T into V infinity. It is, and we have sufficient amount of excess power. But if you see the jet engine power and the velocity, this is the power available, this line, and if you see the another line, this is the power required. This is the point where if we drop this thing from here, this is the V max. Maximum velocity you will achieve here wherever it is touching, and in this case your power available and the power required both are same. So that velocity where both are same is called the maximum velocity, and this will happen when you put your throttle to 100%. Full throttle is there, that time whatever velocity you are getting, that is engine power available and the power required by the aircraft is same, that is the maximum speed. And if you see here, the excess power is very less in a jet engine. Excess power is very less, and you see here it is very high and it is very less. So maximum rate of climb occurs when maximum excess power. So in this case you have to fly at this. This is the V minimum drag here, and if you see here, this is less and this is high speed, more speed. So if you want to fly the jet aircraft, you have to fly at higher speed for a more rate of climb. But for a propeller aircraft, you have to fly with a less speed and you will get the more rate of climb. So that is the benefit of the propeller aircraft in comparing to the jet aircraft. So these are my references, that is Anderson JD JR, Aircraft Performance and Design, International Edition McGraw-Hill's, first edition 1999, SL by MA, Aircraft Performance Theory and Practice, AIA Education Series, AIA. Any questions you are asked to in my this email yddwivedi@gmail.com. Please do like and subscribe this channel. Do not forget to touch the subscribe button or hit the subscribe button. Do any comment in the comment box if required. You feel any clarification. Thank you very much for the joining. We will be meeting you soon with my next lecture, that is about maneuvering flight. In that we will be covering turning and the vertical maneuver, pull up and pull down. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.